Question number 30. Diagram shows a cell of negligible internal resistance connected to a switch and two resistors of resistance R and 2R. R and 2R. The circuit also contains two ammeters X and Y. Okay. Reading on X is 4 ammeters. Okay. Switch is opening. So opened. So this is 4 amperes. Which means what? When the switch is open, all the current which starts from here, it comes and it goes like this over here. Which means if V is the potential difference, I can now say V by R is equal to current I, which is nothing but 4 amperes. Okay. Then what are the readings on X and Y after the switch is closed? When the switch is closed, now what will happen? When the switch is closed over here, now the potential difference across this is V again. So this should be V by R, should be the current passing here, I1, right? I1. What is I1 here? I1 is already 4. So this should be 4 amperes, right? So here it should be 4 amperes. What is I2? I2 should now be equal to V divided by 2R, because same potential difference, which should now be equal to half times V by R. Half times V by R. What is half times? What is V by R? We already know 4. 4 over here. So if you substitute this becomes 2 amperes. So therefore, X, so here it is 2 amperes. Here it is 2 amperes and here it is 4 amperes. What is he asking? What are the readings on X and Y after the switch is closed? After the switch is closed, so here it is 2 amperes. That means the ammeter Y will read 2 amperes. Ammeter Y will read 2. Array is only one option, 2 amperes. Answer is C. How do you see? Did you calculate this value? This is very easy. Say 2 plus 4 is what's the current which comes from here. So which should be equal to 6 amperes, right? So therefore the 6 amperes, there's a current which is passing through X is 6 amperes. 6, this Y is 2 amperes.